Hello, grade 10s. Welcome back. If you are watching this, it probably means that Christmas vacation is over and we're back to doing classes online again for this week. And you're going to do 4 more lessons this week, lessons 5, 6, 7, and 8. And then after you do those 4 lessons, there's a final assignment for Unit 5. And that final assignment is in OneNote, but I also gave some of you a hard copy if you were in class before Christmas to get it. And you're going to send pictures of that final assignment to me. And just remember that that final assignment is taking place of the exam, so it's a big deal. It's going to be worth a lot of marks, and if you spend some time on it and do it right, you could really boost your mark. Okay, so keep that in mind. Sorry, my mic is just all tangled here. One sec. Okay, there we go. So for Unit 5, Lesson 5, we're going to be interpreting and sketching graphs. So the second half of this unit, we're going to be dealing with graphs a lot, whether that's interpreting them or drawing them ourselves. So for this lesson, I'm going to refer to the examples on page, whoops, that didn't work. Page 278 to 280. You don't have to open your textbook though, because I scanned the textbook and just plopped them in this OneNote. So no need to go get your textbook, but if you ever want to look at these examples again and see the textbook solutions, how they explain them, you can certainly do that. Okay, so example 1, it says here that each point on this graph represents a bag of popping corn, which we normally call popcorn. Explain the answer to each question below. Which bag is the most expensive and what does it cost? So if we look at this graph here, we can see that we have a graph that has mass in grams on the bottom. So that's its weight, how heavy the bag is. And then up the vertical axis, we have cost in dollars. And then we have a whole bunch of plotted points. So if we want to find the bag that's the most expensive, that's cost, right? That's dollars. We would look at the point that's highest. So this guy right here, that's the highest point on the graph, which means it has the highest cost. And if we look over, we can see that it lines up with this blue line right here. And if we have to fill in the blanks here, we can see that every tick is worth 1. So 1, 2, 3, 4, 5, 6. So that must be at 7. So my answer here is bag C. And then what does it cost? It costs $7. And we're done. We just interpreted a graph. How good are we? All right, next question. Which bag has the least mass, meaning which bag is the lightest? Okay, it weighs the least. So when we're talking about weight, we're looking at these numbers here. And if we want the least mass, we want the bag that's furthest to the left. We don't want a bag over here. Those are heavy. We want the bag that's lowest or to the left the most, which is bag B. All right, so that has the least mass, bag B, and what does it weigh? So now we're not going to look over to the left because that's cost. We're going to look down to figure out how much it weighs. And so if we look at the graph here, this is 400. That means that this tick right here must be 200, and we're jumping every tick by 200. So we have 200, 400, this one right here would be 600. So we're halfway between 400 and 600. Halfway between that is 500. So it weighs 500 grams. All right, next one. Which bags have the same mass? Okay, so we want to find 2 bags that when we look down, they're over top of the same mass. Well, those would be those guys right there, because E is over top of 1800 and D is also over top of 1800. So that means both bags, D and E, weigh the same. They have the same mass. So it's bags D and E. And then it asks, what is this mass? Well, I already answered that. They are both over top of the blue tick that represents 1800 grams. Okay, which bags cost the same. So now we're back into cost. So if we want two bags to cost the same, and cost is the vertical axis, we're going to find two bags that line up on the same tick over here. And those would be those two. A and E both line up with 4. So bags A and E are both $4. And they are $4. So they cost the same. Okay, and last one. Which of bags C or D has the better value for money? Okay, this is a bit deeper of a question. So a better value for money means you get more for less money. So if we look at bag C and D, they're asking us to look at those two bags. Let's just figure out what C is telling us. So bag C is telling us that we will get 1,600 grams, right? It's over top of 1,600, and we'll get that for $7, right? Bag D is telling us that we're going to get 1,800 grams for only, if we look over to the cost here, well, this would be 5, and we're halfway between 5 and 6. So when we're talking about money, that would be $5.50. So if we look at those two, well, for this option here, I'm getting more popcorn for less money. I would be silly to buy that because I'm getting less popcorn and I'm spending more. That's just goofy. So the answer here is simply bag D. Better value for money. And we're done, question 1. Next one. Each point on this graph represents a person. Explain your answer to each question below. All right, so which person is the oldest? So if we look at the graph here, this graph says it's ages and heights of people. Down here is their age, so we're only talking about people up to 20 years old. And then this way, right here, is their height in centimeters. All right, so if it's saying which person is the oldest, we're going to look at the age. And we're going to look at the highest age, which is this guy right here. So G is the oldest. And what is her or his age? If we look at what number he's over top of, that's 18. And we're done. How easy is that? I just got to scroll up here to see this question. Which person is the youngest? What is her or his age? So the youngest would mean we're going to look at the age here, but furthest to the left. Well, look at this. We have someone who's on the 0 for age. Okay, so obviously we're talking about a baby here. So which person is the youngest? That's person A. And what is her or his age? 0 years. So they just haven't had their first birthday yet. That's all that means. And they're short, obviously. Which two people have the same height? Okay, so now we're talking about height, which is the vertical column. So we want to find two dots that line up with the same value here on the left, one of those guys. And if we look, we see that B and C both line up with 100. That means people B and C are the same height. So B and C are the same height. And what is this height? Well, we said they both lined up at the 100 centimeter mark. So they're both 100 centimeters. D, which two people have the same age? All right, so now we're back to looking at the horizontal axis, which represents age. And I want to find two people that are stacked over top of the same age. Well, there it is. E and D are both stacked over top of that blue line. We can see here that we're jumping by 2. So 2, 4, 6, 8, 10. All right. So our answer is E and D have the same age, and their age is 10 years. And finally, which of person B or C is taller for their age? Okay, so we're going to compare B and C just like we did in the last question. So first, if I'm talking about person B, okay, we know that person B is 2 years old and is 100 centimeters. Person C is 3 years old, right? Because they're halfway between the 2 and the 4 tick down here. And they're also 100 centimeters. So the question asked, who is taller for their age? Well, obviously, he's a bit taller for his age because he's only 2 and he has the same height as a 3-year-old. So that 2-year-old is pretty advanced for his age. So that's our answer. We just say person B, okay? Because they were already 100 centimeters at 2 years old. Okay, this is a different type of question. This is a question where you have to describe someone's journey, okay? And we talk about segments. So describe the journey of each segment of the graph. And there is a question like this in your final assignment, okay? So this graph is in segments. Here's segment 1, segment 2, segment 3, segment 4, segment 5. Okay, you see how those are defined? It's just any change of direction will be a new segment. And they're also labeled with letters. So if we're talking about our segments, we have segment O to A to B, B to C, C to D, and D to E. Those are our 5 segments. That's how we label them. So I want you to do that. Use the letters to label them. Okay, so this graph here is comparing time in hours and distance in kilometers. Okay, so maybe, oh no, sorry, I was gonna make up a scenario, but it says right here what the scenario is. It's a day trip from Winnipeg to Winkler, Manitoba. So someone got in their car, went for a little holiday for a day. So from O to A, it's asking us what happened. So from O to A, they obviously start driving, and they start driving for 1 hour. So from O to A, they drive for 1 hour. So we've taken care of the time. And then we look at how far they drove. So to figure out how far they drove, we have to kind of look over here and estimate what tick we're at. Okay, so halfway through, if this is 60 and that's 80, exactly halfway through would be 70, but we're not quite at halfway. I would say we're at about 65, okay? So here you say 65 kilometers in 1 hour. Done, and we move on to the next one. So for the next one, if we look at time, this right here is halfway, so that would be a 1.5 hour mark. But if we look down, we're only halfway through that. So if you think of time, we have 1 hour to 1 hour and a half. What's between that? That would be 15 minutes. Okay, so this little chunk of time right here is from the 1 hour mark to the 1 hour and 15 minute mark. So it's only 15 minutes. Don't tell me that we're at an hour and 15 minutes. That's how much time has passed in total. We're not talking about that. We're only talking about this tiny segment right here. That is only 15 minutes. Then we have to ask ourselves, how far did we go? Well, look at our distance. Between A and B, we didn't go anywhere. We were at about 65 kilometers and we stayed at 65 kilometers. So what does that tell us? That tells me they took a break. Maybe they stopped and got gas. Maybe they stopped to go pee. They stopped to get a snack, get a coffee. The lineup at Timmy's was really long, but they were taking a break for 15 minutes because they didn't go anywhere. All right, okay. Next segment is B to C. So they start driving again. So we have to figure out how much time has passed between B and C. So remember, this point right here, our starting point is at about an hour and 15 minutes. And then they stopped at the 2 hour mark. You do not write down that it's been 2 hours. Yes, it has been 2 hours in total, but we're not talking about that. We are talking from only B to C. So from B to C, from 1 hour and 15 minutes to the 2 hour mark, that's actually only 45 minutes of time that's passed. And how far did they go? So they started at the 65 kilometer mark and they ended up at the 130. You do not write down 130. You're only telling me how far they went in that segment. So from 65 kilometers to 130 kilometers, to figure that out, you find the difference between the two. You're going to go, okay, 130 kilometers is where they ended up, and you're going to subtract the 65 because they had already gone 65. So in that segment, they actually only went 65, okay? 130 minus 65 is also 65. So they went another 65 kilometers in 45 minutes this time, okay? So make sure you're only calculating the stuff for that segment. That's the big mistake here. Okay, we're on to this segment now. We're at a horizontal line again. If we look at AB, a horizontal line there meant it was a break. But this is a pretty long horizontal line. And then if we pay attention, after this horizontal line, they start traveling home again. They start their route of return. So this must mean they got to their destination, right? Okay, so they got to Winkler, and in terms of time, they got there at the 2-hour mark and they left at the 4-hour mark. So that is a span of 2 hours. So they got to Winkler and they stayed there for 2 hours. So here you say arrived and stayed for 2 hours. Okay. All right. And finally, this last one here, clearly they're driving home. They have no breaks. We have no horizontal lines, no break in the graph there. They start at the 4-hour mark and they get home after the 6-hour mark. Don't write 6. That's only a span of 2 hours, okay? And they drove 130 kilometers. That's where they were, all the way down to 0. So this is a whole drive of 130 kilometers home. So, I mean, there's different things you could write. You could say they returned the 130 kilometers home in 2 hours. You could simply say 130 kilometers in 2 hours. I'm not too sticky on the detail here, as long as you have the distance and the time. That's what I'm looking for. Okay. All right. Last question. This one's a little bit different as well. I give you a scenario. Oh, sorry. I'm skipping ahead. This graph represents a day trip from Athabasca to Kikino in Alberta, a distance of approximately 140 kilometers. Describe the segment. Okay, so we're doing a segment thing again, but I'm going to go a whole lot quicker here because we just did one. So for segment O to A, if we look at our graph here, time and distance again, same type of scenario. O to A, they're clearly doing a straight shot, no breaks. They go from 0 up to 140 kilometers in 2 hours. So 140 kilometers is what they drove in that span, and that span was 2 hours. Done. A to B, a horizontal break usually means they stop, okay? Here they stopped from the 2-hour mark to the 3-hour mark, so it's only 1 hour though that they stopped. So you can say stopped for 1 hour, or they got to their destination for an hour. We know they got to their destination because after that they start heading home. They start their return path, okay? B to C. So from B to C, they go from the 140 kilometer mark down to about the 90 kilometer mark. Don't write 90. 140 to 90 is a distance of 50 kilometers. You just go 140 minus 90. They drove 50 kilometers in the time from B is right here, C is right here. Okay, so if this is 3.5 hours, halfway through, we're not quite at 4, that would be 3 hours and 45 minutes, 3 3/4 hours. Okay, C to D, I'm assuming they took a break in their car, and that break was from the 45-minute mark, or this mark right here, which is 3 hours and 45 minutes, is this mark here, until the 4.5-hour mark. So you got to figure out from 3:45, 3 hours and 45 minutes, to 4.5, how many minutes passed? That's 45 minutes. And D to E is a straight shot home. They were at 90 kilometers. We know that from our B to C segment. We figured that out. This is at 90. and they drove all the way down to 0. So they drove the return 90 kilometers, and they did that from the 4.5 hour mark to the 5.5 hour mark. That's 1 hour. And we're done. Okay, so the hardest part for this is usually the time. You know, if we're talking about quarter hours and 45 minutes and this and that, you may have to take a minute and just think about how many minutes, take a minute, haha. Think about how many minutes are in an hour, 60. Okay, and if we're talking about quarter hours, every quarter hour is 15 minutes. Okay, there's 4 chunks of 15 minutes in an hour. That might help you. All right, this one here is where we have to draw. So Samuel went on a bike ride. He accelerated until he reached a speed of 20 kilometers an hour. He's rolling at 20 kilometers an hour. He did that for about 30 minutes. Samuel arrived at the bottom of a hill, and his speed decreased to approximately 5 kilometers for 10 minutes as he cycled up the hill. He stopped at the top of the hill for 10 minutes. Sketch a graph of speed as a function of time. Okay, now bear with me here as I try to draw this graph, okay? So usually we have time at the bottom, and if we read the question, it's all in minutes. Okay, he did this for 20 minutes and that for 30 minutes, etc., etc. So we're going to use minutes. And then on my vertical column, it is talking about his speed. So it tells us right here what we want you to do. Speed as a function of time. So speed and time are 2 labels. So this is speed. Okay, and they tell us in the question that the speed is in kilometers. Okay. So usually, now I'm going to try to do I'm going to try my ruler. I've never done this before. Oh my gosh, what just happened? So I wonder if I can line this up and draw a straight line. Oh, that works. Oh my God, that's so sweet. Okay, and then I'm going to flip it. So I'm just kind of drawing my labels here. Okay, I'm going to push that to the side. Okay, all right. So 4 minutes, we have to figure out how long this whole thing was. So he accelerated and got to 20 kilometers an hour, and he did that for 30 minutes. Okay, then he got to a hill, and then it took him about 10 minutes to get up that hill, and then at the top he stopped for 10. So this whole thing is 50 minutes. Okay, so down here we have a lot of room. We want to get up to the 50 mark. Don't jump by 10. If you jump by 10, we're already at 50 right there. Let's spread out a little bit. Oh no, I just erased my pretty line. I know this is like a super long lesson, so if you want to fast forward this painful part of me doing the ruler and kind of get to the final answer where it's all drawn out, you can do that, and then I'll explain what I drew. That might be easier. So if you want, you can fast forward a minute or two. I'm going to draw it out, and then I'll explain what I drew. All right, and if you're still listening, I'm just doing my ticks here. I'm going to do 2, 4, 6, 8, 10 minutes, 2, 4, 6, 8, 20 minutes, 2, 4, 6, 8, 2, 4, 6, 8, 30 minutes, 2, 4, 6, 8, 40 minutes, 2, 4, 6, 8, 50 minutes, 2, 4, 6, 2, 4, 6, 8. So I have 60 minutes fitting in, okay? Speed, his max speed that he gets to is 20 kilometers an hour. That's as fast as he goes. So I'm going to just do one tick. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, there's my ticks. Now we're going to draw what happened. So right away, it says he got on his bike and he accelerated until he reached a speed of 20 kilometers. So once you get on your bike and you start pedaling and you accelerate to 20 kilometers, it doesn't take you a long time. And the question doesn't actually even tell us how long it took him. But imagine getting on a bike and pedaling as hard as you can to get up to only 20 kilometers an hour. It will take you just seconds. Okay. So what I'm going to do is I'm going to say he got to his 20 kilometer mark, like pretty much right away, like pretty much on the 0 line. Okay, that's like our 0 line. It took him no time at all. Then it says that he was there for 30 minutes. So there's the 30-minute mark. So he stayed at this speed for 30 minutes, okay? But remember, if he's there for 30 minutes and it took him like a few seconds to get there, we're just right after the 30-minute mark. So there, he's been there for 30 minutes. Then he got to the bottom of a hill. So when you get to the bottom of a hill, his speed decreased to approximately 5. So he's riding his bike, he gets to a hill, and as he starts mounting the hill, his speed declines. And his speed declines down to 5. So here's the 5. Okay, and that's his speed now. But he's at that speed for 10 minutes. So we're just after the 30. So we need to go to just after the 40 to be a span of 10 minutes. And then once he got there, he stopped at the top of the hill for 10 minutes. So if you stop, your speed is 0. And he was at a speed of 0 for 10 minutes. So we're right after the 40 mark. So now we're right after the 50 mark at 0 for speed. Now what we do is we just connect our segments. So he starts at 0. I'm going to change my color here. Starts at 0 and he accelerates pretty quickly. Then he is at a speed of 20 kilometers an hour for 30 minutes. Then he slows down drastically because he gets to a hill. Then he's at that hill, he's mounting the hill at a speed of 5 kilometers an hour for 10 minutes. And then once he gets there, his speed, whoops. Oh, sorry. Let me just, where am I here? So he did his 30 minutes. He mounted the hill for 10 minutes. So this is where he's mounting the hill at a speed of 5 kilometers. Okay. Actually, I did this wrong. I'm having a brain fart here. This dot wouldn't be right here, actually. Oh, my stupid line. So I'm sorry, guys. So this here says that he was at a speed of 5 for 10 minutes. That was him climbing up the hill. So he's at a consistent speed of 5 for 10 minutes. And then right here is where he gets to the top of the hill. And boom, as soon as he gets to the top of the hill, his speed drops down to 0. And then he's there for 10 minutes. He's at 0 for 10 minutes. So sorry, that's what that should look like. So he gets to the hill right here, top of hill. His speed goes down to 0 immediately once he gets there, and he stays at 0 for 10 minutes. Okay, and we're done. Sorry, butchering this so bad. I know, I'm not sure I like this ruler thing. Okay, so you guys fast forwarded a little bit. If you're just joining me now, I'm just going to quickly explain what I drew. It's not letting me draw my ruler, draw my line. What the heck? Okay, I'm just going to freehand it. Screw it. Okay, so this is what we have. Right here is where he accelerates, and it takes him barely any time at all, seconds, okay? Right here is where he is going 20 kilometers an hour for his 30-minute bike ride, okay? This is where his speed decreases. And then this is where he's mounting the hill. I can't even read that word myself. What did I just write? We'll say climbing the hill. He's not really climbing because he's on a bike, but climbing the hill is right here. Then he's at the top of the hill, and then he slows down, stops for 10 minutes. Okay, so I chose this one because it is complicated. You can see even I kind of had a brain fart at the end there, if you were watching that. The one on your final assignment is a lot easier. It's a lot more clear, and it's actually similar to these guys here. It's more of just going on a trip there and back, okay? So just remember that when you're doing your assignment, you can always come back to these guys and watch this video again for me to explain these, okay? Here is your assignment, a couple questions from the textbook, and you can always email me if you have questions about this stuff. Good luck. Sorry for the long video.